Hello everyone, welcome to our Module 1 lab video. My group was tasked with task number 4. Our group was Tyler Dean, Max Provich, Zach Howell, and Taylor Heiner. The purpose of our lab, or task 4, was to explore and shape the relative sizes of ions and crystal structure of ceramics. We also had to explore and explain the difference between metals and ceramic structures. The difference between metal and ceramic structures starts with a cation and anion ratio. That is when the coordination number increases with cations over anions. The difference between metals and ceramics is that metals structures, or the cations and anions, never change, while the cations and anions change in ratio in accordance to whatever the ceramic is made of. What we used to make the structures for our lab was various arts and crafts materials such as hot glue, popsicle sticks, foam balls, string, and hot wires to cut the foam balls.
The first structure that I'm going to introduce is called linear. Linear structure is comprised of a cation with two anions located on opposing sides. The cation to anion ratio is less than 0.155. The coordination number is 2. A common example is copper chloride, and it is commonly used in electroplating. The next structure that I'm going to introduce is called trigonal. The trigonal structure is comprised of a cation surrounded by 3 anions. The cation to anion ratio is from 0.155 to 0.255. It has a coordination number of 3. An example is mercuric triiodide.
The next structure we built was the tetrahedral structure. This structure is similar to a triangular pyramid, and the ratio in this structure of the cation to the anion is 0.225 to 0.414. The coordination number of the tetrahedral is 4, and an example of the tetrahedral structure would be zinc blende. The final structure we created was the octahedral structure. The octahedral structure takes the shape of the octahedron. The ratio of the cation to the anion is 0.414 to 0.731. The coordination number of the octahedral is 6, and an example of an octahedral would be perovskite.
One of the structures that we had to build was a sodium chloride or salt crystal. This takes the octahedral shape, which has a coordination number of 6, and we used anions that were twice as big as the cations, which gives us a ratio of 0.5, which is good for an octahedral. We built this one out of popsicle sticks and stuck them through the foam balls. All of these are loosely held together with ionic bonds with only touching the oppositely charged atoms.
And that is the end of the video. Thank you everyone for watching. Please like and subscribe for more labs.